In my last video, we use a monitor vehicle tracker as a game engine. Let's examine the code once again. First, the monitor vehicle demo is stateless. We don't need to worry about the state variables of this class. The game board have several state variables. Those public static final we don't need to worry about. First, they are primitive variables, and they are static final. Immutable primitives are always thread safe. We don't need to worry about their initialization safety and their visibility or atomicity. They are always thread safe, so it's make our analyze a little bit simpler. Now let's take a look at those state variables. dx, dy, they are not final, and we need to worry about their publication safety. Also, your tank, laser beam are mutable, are reference to mutable objects. We need to worry about their initialization safety. Start button have the same nature, and also the monitor tracker. By further analyze, we realized the dx, dy, your tank, laser beam, start button are only used in a single thread, so they are confined inside the event dispatch thread. They are not shared, so we don't need to worry about their synchronization. But as a good habit, we use a static final so that in the future they will be shared if they will be shared in multiple threads, we already have the initialization safety. The only variable that is shared among multiple threads are this monitor vehicle tracker. So since the monitor vehicle tracker have internal states and it is a mutable variable, we need to pay attention to two aspects. First, we need to safely publish it. Two, we need to make sure sharing this object is thread safe. By declaring this variable as volatile, we achieved initialization safety. In other words, when the empty is referenced in another thread, the consuming thread is guaranteed to view the as published state. Secondly, the monitor vehicle tracker itself is thread safe. We achieve the thread safety by confining its state variable inside this monitor vehicle tracker. We use the monitor pattern. Even though the locations contains mutable point, the mutable point is never published, and the locations, this map never published outside the monitor tracker. Whenever we need a reference, we need to returning a reference of locations or mutable point to the caller. We do deep copy or we create a new mutable point. So the locations never published, the mutable point never published outside the monitor tracker. And the access to this state variable is guarded by synchronized keyword. So every access to the locations either update, either get or set is guarded by synchronized. So this mutable, so this state variable uh, is guarded with a monitor pattern, and monitor vehicle tracker is thread safe, even though the mutable point is not. And this approach have several problems. First, by using synchronized, and at any time, only one thread can access the locations. Secondly, we do deep copy, or we create a new instance whenever we need to return a reference to locations or its mutable point. This could have performance impact if we have a large set of locations. Again, by doing deep copy or create a new instance, we return a snapshot of the underlying map or mutable point. So, in other words, even though the locations has changed or the mutable point has changed, the caller will not see the update. What the caller see is a snapshot from a past time, so it could see stale data. This won't be a good feature if we have a GUI trying to update the most recent view of the locations. We can fix this if the mutable point became immutable. Then we don't need to return a new constructor every time, because immutable point can be published with any mechanism. Also, we have only one state variable. If this state variable, let's go check chapter 4. Okay. If a class is composed of multiple independent thread-safe state variables and has no operation that have any invalid state transitions, then it can delegate thread safety to the underlying state variables. So we can delegate our thread safety to the underlying state variables if the state variable is thread safe and has no operations that have any invalid state transitions. Okay, so if a state variable is thread safe, does not participate in any invariants that constrains its value, and has no prohibited state transitions for any of its operations, then it can be safely published. In other words, if we can make locations thread safe and make the mutable point immutable, we don't need to do the deep copy. We can return a reference of the point to the caller, knowing it is immutable. So in the next section, we will use another vehicle tracker. We will delegate our thread safety to the state variable, and changing the game engine is really simple. We just need to do the string replace, because the two game engine have the same public API. Okay, see you next time.